Alright, hello everyone. In this video we're gonna talk about fault tolerance in fault tolerance proxy and load balancing. It is the continuation of the last video that we talked about how to configure like simple network using HAproxy and configuring load balancing. In this video we're gonna go more into detail and how to configure a bigger network. So whenever you want to do load balancing and proxying in open source environment, you always find two best solutions, Nginx and HAproxy. These two are the most popular solution right now in the market, and whenever you want to pick up the best solution for load balancing, you have to finally choose between these two. So it's very important to know the features of each of them to be able to select the one which best serves your requirement. So Nginx is a full web server, while HAproxy is only a load balancer. So if you want to have your load balancer and web server in the same machine, go for HAproxy. And then Nginx is more complicated and slower, not very slower, but a bit slower because it has web server and load balancing feature in the same software. And HAproxy is a bit faster. HAproxy works only with open source solution, where Nginx works with open source as well as Windows. HAproxy comes with the admin console, while Nginx doesn't have that option. Nginx works with HTTP layer 7, as you see here, but HAproxy works with layer 7 as well as layer 4 TCP, which is a huge advantage for HAproxy because it doesn't need to open the packet. Only reading from the IP header, it can redirect your request to one of the backend servers. Nginx provides good caching, while HAproxy is more advanced and robust solution for routing and load balancing. Both support SSL. So whenever you want to choose between these two, you have to see your requirement. If you want to work with uh, you want to have your web server and load balancer in the same machine, go for Nginx. But if you have your web server in separate machine and you have dedicated machine for HAproxy, for load balancer, go for HAproxy. So as we said, HAproxy is fast and reliable. It is implemented by C, that is why it is fast. And also many big websites like Stack Overflow, Reddit, or even Twitter use HAproxy. This is the architecture that we're gonna implement today. As you see, we have minimum requirement, which is four backend server, PRI1 through PRI4, but it can be hundreds of them, doesn't matter. And we have two load balancer here, HA1 and HA2, and we have a domain name which client can access our network through that domain name. And as you see, load balancer are connected to backend server as well as connected to each other. Connecting to each other is a bit challenging, but I'm gonna show you how to do that part also. To start our configuration part, there are some requirements. You have to know about SSH, how to access a remote machine using command line, and also you have to know about DNS and DNS zone. Because here, as you see, I have a domain name which has two IP in the backends. Each HAproxy has an IP, and domain name will resolve the name to one of these IPs randomly. So I'm not going to show this configuration, and that is not a very challenging part of it. You just need to create a zone and create a record with two IP addresses in the backend. So we're gonna install HAproxy and then enable it because by default it is disabled, and then we do the configuration part of it, and then we have to pair up two HAproxy nodes and then do the testing part. HAproxy, as we talked about it in the last video, has different balancing algorithms. Round robin, source, least connection are the three most important ones. Round robin sends the request in turn, one for each backend server. Source will redirect the request based on the source IP address. And the least connection means this request will be sent to the server with least number of connections. And the modes, as we said, HAproxy works with HTTP and TCP modes. So let's go ahead and see how it looks. Here is my network. I have 4 backend server and I'm accessing them remotely through SSH. So this is one server, this is one server, this is one server. So I have 4 backend server, PRI1 through PRI4. And I have 2 HAproxy, HA1 and HA2. And here is my client. So for the backend server, as we talked in the last video, we have Apache 2 and Assault. And we have a simple web page. So if you say curl localhost, you will get a simple web page saying I'm server 1. And the same thing for server 4. So server 1 through server 4, Apache 2 and Assault with a simple web page. We come to HAproxy. Here is our configuration part. So as we talked in the last video, the configuration file is here in this path, etc HAproxy config. And when you open it, let's open it up. Today we're going to talk about all the options inside the configuration file. The log file, the log decides where your logs should be saved. Right now I have it in my local machine, but it can be any remote machine with syslog enabled. And here you decide your socket, and here are the user group. Of course, if you have any network, you have user groups with different permissions that you want to apply it on HAproxy as well. So you can put any user in group based on your system requirement. And here we define that HAproxy should be run on background as a service. As we here SSL, as we said, HAproxy natively support SSL means if you have an encrypted channel and you encrypt the data between the client and server, you have public key for the client and private key for the server. Here you have to define your private key, so load balancer can encrypt and decrypt the request from the client and from and to the client. Here are our default configuration. When you install HAproxy, these come by default, and you may want to change it or you just keep it like this. The log will be global, it will log everything, and the mood is HTTP right now. Let's try the mood HTTP in the client. I'm in the client right now. I will say, let me clear up everything. Okay. So I can say curl ha.computerscience.loyola-university-chicago.edu. This is my domain name. You can try it from your home as well. Whenever I access this domain name, it will result to one of the IP address of my load balancer, and I will access here and here, and this load balancer will redirect my request to one of the backend servers. Let's go ahead and do that. As you see, I'm getting response from server 1, and server 1, and server 2, and server 3, and server 4. So why I get sometimes 2 responses from the same server? Because these 2 load balancers don't know each other. We have to introduce these 2 to each other. And the other point is, you see it is a little bit slow because right now we are using the mood HTTP here. But I'm gonna go ahead and change it to TCP. Why we should have HTTP? HTTP is layer 7, so if you have multiple applications in the same server, you have to open up the packet and based on the content of packet redirect it to one of the servers. But if you don't have multiple applications in the server, you may want to choose TCP, which is faster because it's not gonna open the packet only based on the IP header. It will send it to one of the backend server. So I'm gonna go ahead and change the mood to TCP. In the same time, here is the balance. Here is my algorithm, which I have defined least connection. Means the request will be sent to the server with least number of connection. You can change it. I'm gonna change it to source. The source means same IP address will be sent to the same server always. So save it and reload HAproxy. Awesome. And the same thing for the other one. I open it up. I change the mood to TCP. I'm changing the mood to TCP, and also I will change the balancing algorithm from least connection to source. How about the other options? This option, as we said, the log will be, if we are in the TCP mode, the log will be TCP. If we are in the HTTP mode, the log will be HTTP. The options here, there are a lot of options available. What you want to log. Right now, it will log everything, but you can define log only unsuccessful request, log only error, log only, or log in the different files. So you can. There are many options available here. You can specify the way you want to keep the logging. And here is the timeout. The timeout is in millisecond. Right now it is 5 seconds for connection, 50 seconds for the client, and 50 seconds for the server. So if there is no request coming back and forth, the the connection will be timed out after 50 seconds. And here is where the log files will be saved. The 400 for the client error and 500 for the server error. And I define my front end, any arbitrary name. I specified my front end, and then that is bind to port 80. And then I define my backend server. The balancing algorithm is source now. The mood is TCP, and I have 4 backend server. I'm doing the checking, means before sending any request to the client, the server will check to make sure that the backend server is up and running. So let's go ahead and save it and reload. Now if I come to my client, um, I expect to see a faster response as well as response from one server because we changed the balancing to source. So I should receive the response only from one server. Let's go ahead and see how it works. Server 3, server 3, server 3, and like this. Okay, the next step is to pair up these two HAproxies because right now we have specified this configuration, but we don't have this connection right now. We have to pair them up. Before doing that, you have to make sure you have the latest version of HAproxy installed because the older version of HAproxy doesn't support pairing. Only the version 1.5 and latest will support HAproxy pairing. So make sure you have the latest version. You can download the newer version and install it. Or if you are in Ubuntu, you can do it through this command. Here, you have to run this command, which will enable a dedicated PPA for HAproxy 1.5, which is the latest version in the time that I'm making this video. So you have to go ahead in your project and say this. Uh, After doing that, you have to update your repository and install HAproxy, which will install the latest version of HAproxy for you. And after that, you have to pair up the two HAproxies. I have already updated my HAproxy, so I'm gonna go ahead and do the configuration part. Okay. At the very bottom, right now you see we have like 4 sections: global, default, frontend, and backend. The next one can be peers. Peers is keyword, and then you define your peer. I think I have the code here. Yeah. So I don't want to type it. I will just copy and paste it here. Awesome. So peers is keyword, my peer any name, and then you have to define 2 peer. I have HA1, HA2 with these IP addresses, and then my port is 1024. It can be any port but not 80 because it will conflict with those. So you do this, and after that you have to make sure you dedicate a memory for HAproxy because this node should keep a status of the other node while working to make sure if that the other node goes down, this node is still can provide the service to the client. So for doing that, we have to create a table in the memory for HAproxy. Here you have to go to the backend section here, and then I will define the stick table with type for IP address, and then the size you can put any size. I will put 20K, that's enough. And then you have to define your peers. My peer is the one that I defined here at the bottom. So you do the same thing for, okay, we save here and reload to make sure everything is fine, and the same config for the other one. I paste the code here and then define the table, which will create a table on memory for keeping the status of each other. Sorry. Take table and type for IP, and the size, any size, I will put 20K, the same configuration for the other one, and the peers, my peer, which I define at the bottom. After saving this and reload, if you reload and see any complaint about the peers, it means your HAproxy is not updated. You have to go ahead and update your HAproxy. So right now I have configured these two, so now these two HAproxy nodes know about each other. Now if I request, I will still get the same response from the same server because I defined the uh, uh, algorithm to source. I will go ahead and change it to another algorithm, which is round robin. It will distribute the workload in turn one for each server. So round robin, mm, save it and reload. Same thing for the other one. Save and reload. Awesome. Now we come back to the client. Let me clear up everything. So I have to receive the response from different servers. One, server 2, server 3, server 2, server 3, server 4, and like this. The good thing about this architecture is that we have fault tolerant. What does it mean? It means the whole idea behind this project was if anything happens to some of the uh, server, backend server, or load balancer, still the client should get response from the server without facing any issue. So let's go ahead and test that. I will bring this backend server down by stopping the Apache server. So I'm gonna go ahead and say service Apache 2 stop. Type your password. Okay, so this server is down, and I will bring this one down as well. To stop. Oops. Okay. Typo. Okay. Now I have two servers down, so the client should receive the response without any issue. As you see, the client will receive from server 2 and server 3 without any problem. Let's bring one of the other down. Sudo service Apache 2 stop. Awesome. Okay. Apache 2. Okay. So right now I have only one server. but the client faced no issue, you see, getting the response with no problem. So now let's go ahead and bring one of the load balancer down to see what happens. I have two load balancers that know about each other. Let's stop one of them. HAproxy, stop. So right now I have only one load balancer and one backend server. Let's see how it behaves for the client. Awesome, see? The client can get response without any issue. Right now I have half of my network down. Just think there are different machines. So this machine is unplugged. This is the network cable is unplugged. This one is the hardware is the hardware, or I don't know, any part of the machine has stopped working, and also load balancer crashed. But still, the client can get response without any issue. That is the concept behind fault tolerance. But of course, if I stop the last load balancer, everything crashes. Stop. You see now the client cannot get any response because we don't have any load balancer now. So start it, and now the client can get response. So as far as I have one load balancer and one backend server, everything works fine for the client, and you can take down your damaged machines, fix it, and put it back without disturbing the service for the client. So we successfully uh, implemented this architecture. The next thing you have to know about HAproxy is the logging and monitoring options. HAproxy can provide different type of logging, advanced type of loggings that you can read here. You have to specify the logging option which works best for you. And also, HAproxy has monitoring option. It means you can query HAproxy and ask about the status of the machines in the network. Uh, Using this option, you can always query your load balancer and make sure the service is running without any problem. So this was all about HAproxy and load balancing. Once again, before pairing up these two nodes, you have to make sure you have the latest version of HAproxy installed, otherwise it's not going to work for you. And let's open up the error log to see what happened during the time that we were testing. So I'm going to go ahead and open up the log file. The log file, as we said, is here in the um, etc HAproxy. Uh, oops, let me check the path one more time. Okay, etc HAproxy errors, and then okay. So if you come here and see, oops, mhm. So I have to just cd, and now if you list everything, you see I have 400s which are client errors, and 500 which is specified the server error. So let's open up one of them. I will open 400. You see, we had one bad request from the client, and also we had our server down for a couple of minutes, so we have to have something in the 500 as well. As you see, server error happened because of any internal problem. So these are the log files that you can use to discover any problem in your network. I hope you enjoyed the video, and make sure you implement that to learn more, and don't forget to like the video.